everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic solutions for class 12 2025-26 and this is part 4 of the chapter. Today we will see vapor pressure of liquid solutions. Now how do we get liquid solutions? Liquid solutions are formed when the solvent is a liquid, the solute can be gas or a liquid or a solid. In this we will see vapor pressure of liquid solutions. Now in a binary solution of two volatile liquids, the two components can be denoted as 1 and 2. Both are volatile liquids. When taken in a closed vessel, both the components would vaporize and eventually an equilibrium will be established between vapor phase and the liquid phase. So if the total vapor pressure is P total, P1 and P2 are the partial vapor pressures of the two components 1 and 2 respectively. So the vapor pressure, that is total vapor pressure, we are taking as P total. As per Raoult's law, if there is a solution of volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to its mole fraction present in solution. For a solution of volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to its mole fraction present in solution. So for the component 1, P1 is directly proportional to X1 because just now we have seen partial vapor pressure is directly proportional to mole fraction. And to remove this proportionality sign, we get P1 is equal to P1 naught X1. P1 naught is the vapor pressure of pure component 1. Vapor pressure of pure component 1. And all these things are at the same temperature. For component 2, P2 equal to P2 naught X2. Like P1 equal to P1 naught X1, P2 equal to P2 naught X2. P2 naught will be the vapor pressure of pure component 2, P2 naught. Like P1 naught vapor pressure of pure component 1, P2 naught vapor pressure of pure component 2 at same temperature. Now as per Dalton's law of partial pressure, the total pressure over the solution phase will be sum of partial pressures of the components of the solution. Because there are two components, so P total. What is P total? Total pressure over the solution phase. Sum of partial pressure, that is P1 plus P2. Sum of partial pressures of the components 1 and 2, that is P1 and P2. But we know that P1 is equal to P1 naught X1. Similarly, P2 equal to P2 naught X2. So we substitute the values of P1 and P2 so that we get P total equal to X1 P1 naught plus X2 P2 naught. But what is X1? X1 is 1 minus X2. X1 is 1 minus X2 into P1 naught. This term we copy here as it is X2 P2 naught. On removing the brackets, we get P1 naught minus X2 P1 naught plus X2 P2 naught. On rearranging, we get this equation P1 naught plus P2 naught minus P1 naught X2 is equal to P total. So from here, what do we conclude? We can conclude that total vapor pressure over the solution varies linearly with the mole fraction of any component, and depending on vapor pressure of the pure components 1 and 2, the total vapor pressure over the solution will either increase or decrease with the increase of mole fraction of either component. If we plot P1 and P2 versus the mole fractions X1 and X2 for a solution, we get a linear plot. And we see that the minimum value of P total is P1 naught and maximum value is P2 naught when we assume that component 1 is less volatile than component 2. Component 1 is less volatile, so minimum value is P1 naught. And in case we take mole fractions in the vapor phase, so if Y1 and Y2 are mole fractions of the components 1 and 2 respectively in the vapor phase, then using Dalton's law of partial pressure, we get that P1 equal to Y1 into P total, while P2 equal to Y2 into P total. I hope students you all could understand this topic which I discussed today. Thanks for watching the video. Please subscribe to the channel and share the video. Thank you.